Welcome to Study Loop.
Here we are asked if carbon 11 can decay into boron 10 and a proton. And we can investigate the binding energies of this, or energy singular, of this reaction in order to see if it's possible or if it violates conservation of energy. I've written down the reaction here where carbon decays, it loses one proton and becomes boron 10. The mass of carbon 11 in terms of atomic mass units is 11.0011434. I looked that up in Appendix B. Similarly, the mass of boron 10 is 10.012937. And finally, the mass of a single proton, I'm ignoring electrons in this problem, it turns out to be 1.007276 atomic mass units. In order to find if this is a viable reaction or not, we need to calculate the binding energy. The binding energy in this case is the change in mass times the mass to energy conversion constant, which is 9.31.5 mega, capital M, mega electron volts per atomic mass unit. For our case here, in order to find binding energy, we take the combined mass of the constituents. In this case, that's the mass of one boron 10 atom and the mass of an individual proton. We're going to subtract from those combined constituent mass the mass of the parent carbon 11 atom. And again, we want units of energy, so we'll multiply this mass difference by 931.5. Okay. Plugging those figures in, we find that the binding energy here is 17.76 025 mega electron volts. This is greater than 0. So it means that the parent, in our case, carbon 11, is stable. For this reaction to take place without any energy added would be a violation of the conservation of energy. Let's see if I can write that down here. Decay to occur. Without energy being added, would violate. Conservation of energy. And that's our answer. Specifically that. Carbon 11 is stable.